Hey, lockdown, May 2020. A good time for armed robbery, but less so for burglary. I'm Dr. Mark Lewney. My star oh, it's actually going to be alright if the busies turn up. I'm just exercising my chimps. There's my chimps. You just hold that one. Thanks. Right, so my star fact is that in quantum physics, you can actually get something from nothing, right? You might have heard of matter and antimatter, so if that's an electron and that's a positron, an anti-electron. You might have heard that when a positron meets an electron, the two annihilate in a process we don't fully understand to give nothing but energy.
It's in your pocket.
No. Right, this is better, okay? This one's better. Weirder still, what you might not know is that that process can happen in reverse, right? So you can start with nothing but energy, and suddenly a pair of particles pops into existence from nowhere. How does physics explain this remarkable fact? I'm going to try and do it in 10 minutes in one take, but I might need to use a cutscene. Physics explains this remarkable fact by appealing to the Heisenberg uncertainty principle. Now, you might have heard of this in terms of position and momentum. So for a tiny particle, like an electron, you're allowed to know exactly where it is or how fast it's moving, but not both of those at once with infinite accuracy. The more accurately you know one, the less accurately the universe allows you to know the other. The product of the errors has to be bigger than a particular number, but that's a really tiny number, so these effects only become really apparent at tiny scales. I'm going to show you a different formulation of the uncertainty principle that I've drawn on me. Oh God! That I've drawn on me arm backwards with me left hand. Sorry, the phone flips it. Right, what this is saying is that the energy you're allowed to know that a system has, and the time for which that system has that energy is similarly uncertain. If you're not bothered about the time, it can be a fraction of a second or a billion years, then yeah, you're allowed to know the energy very accurately. But at tiny scales, and especially tiny time scales, what's happening is that that time scale has become more and more certain, which means the energy has to become more and more uncertain. At the tiniest time scales, that energy can start to fluctuate, right? Zero is a very certain energy, isn't it? Absolute zero. That's very well known. So at the tiniest timescales, you're not allowed to know it's exactly zero. So what happens is that energy fluctuates, and sometimes it fluctuates enough for a tiny little thing to appear from nothing. It's just a quantum field, which is the nothingiest thing I can think of. Is this equation, Heisenberg's uncertainty principle in energy time form, the most important equation in all of physics? Well, yes and no. It's got strong competition from the equations of gravity, relativity. So what can happen when this tiny little thing pops into existence from nothing more than a quantum field, a vacuum with a particular expectation value? Apparently, gravity can become repulsive. Ugh. This is inflation, the bang in the Big Bang. Apparently, this tiny little thing can naturally become the size of an entire universe. Now that is a mental idea. I guess the question is is it any less mental than God's going, there? Right, now I confess, I'm not entirely sure why theoretical physicists consider this to be a promising candidate. I'm not a theoretical physicist. What I do recommend is this book. Brian Greene's Fabric of the Cosmos. Apparently, it's got to do with a frog in a hot Mexican hat. The tiny little dot thing can apparently become something the size of an entire unit. Oh, you alright? Yeah, just a holiday in me front garden. It can become an entire universe-sized thing, made mainly of hydrogen, with some helium and a bit of other stuff. But the story from now is a lot more straightforward because gravity is attractive. Very slowly, gravity is able to pull these vast clouds of hydrogen together tighter and tighter until it's pulling it so tight that it's able to fuse the hydrogens together to make helium and give off loads of energy. This is a thermonuclear fusion reaction. Completely naturally, gravity has made a massive thermonuclear bomb in space. Like, oh yeah, that one there. That one up there. So this process continues for quite a while. Hydrogen being fused into helium and giving off energy until all the hydrogen is used up. Then gravity pulls the star even more tightly together, even hotter, fuses helium atoms together into other things in the periodic table. Tighter, hotter, it goes through the periodic table until it eventually gets to iron. When it tries to fuse iron atoms together, then the whole thing gets bounced off an iron core, a huge explosion called a supernova that spreads those new atoms through space. So, gravity starts again. It starts with a big, vast cloud of helium, only this time it's seeded with those new atoms. After a couple of generations of this, there's enough new stuff for little spheres of the new stuff to form around a new star. Little spheres like, well, this one that I'm actually sitting on. This is a very hot new sphere, though. It takes a while to cool. Comets deliver water, but it's still very tectonically unstable, so there's a lot of underwater volcanoes. What happens in these underwater volcanoes? Little complex molecules called polycyclic aromatic hydrocarbons form longer and longer chains that allow for longer and longer chains to form. Eventually, a long molecule forms with a very strange property. It can self-replicate. It's a double spiral that can come in half, and each half can grab the building blocks from its environment to make it a double spiral again. And these long molecules find their way into little fatty bubbles. These are the first cells, or at least proto-cells. And these cells, over billions of years, become more and more complex. They start making oxygen. They start coming together into more and more complex organisms. These organisms become fish, then amphibians, then reptiles, mammals, little shrewy things, little lemur-y things, little monkey things, little ape things, Australopithecus, Erectus, Neanderthal. And eventually, there's a kind of chimp that is able to label its world with language. And it uses that language to ask itself the question, how did I get here? Come on in, chimps.